Welcome to the DefCam. India's intent to acquire the S-500 Prometheus air defense system from Russia changes the physics of regional defense calculations and forces a rigorous reassessment of Pakistan's strategic and operational responses. The S-500 is presented by its developers as a strategic layer intended to engage ballistic missiles, hypersonic weapons, and objects in near space at ranges measured in hundreds of kilometers and at altitudes that extend into low Earth orbit. If fielded with the capabilities claimed, the system would expand the defended envelope around deployed batteries and urban centers, complicate the positioning of high-value airborne sensors, and raise the bar for any conventional air operation that relies on freedom of access at long range. From Pakistan's perspective, the first task is to convert this strategic surprise into operational clarity by understanding what the S-500 actually changes and where the persistent vulnerabilities still lie. At the fundamental level, the S-500's advertised ability to detect and engage very high altitude and very high-speed threats makes it primarily a strategic interceptor and sensor node rather than a universal panacea. Long-range sensing at extreme altitudes increases the defended area, but it does not eliminate the physics of tracking and engagement. A single S-500 battery has finite radar channels and a limited number of interceptors that can be guided simultaneously. Against complex threats that include many re-entry vehicles and sophisticated decoys, the system must discriminate, prioritize, and allocate interceptors under extreme time pressure. Pakistan's multiple independently targetable re-entry vehicle-capable missile provides an asymmetric answer to the saturation problem because it multiplies the number of incoming warheads and complicates discrimination. A salvo of missiles deploying multiple independently targetable re-entry vehicles and penetration aids forces a defense to trade off between lucrative high-value targets and the sheer arithmetic of intercepts, and that trade-off preserves deterrent effect. Beyond strategic saturation, practical counters exploit operational and technical seams rather than attempting direct parity. High-value airborne platforms such as airborne early warning and control aircraft become survivable through mission architecture changes, operate at extended standoff distances, use distributed sensing with smaller, low-observable unmanned sensor nodes forward of the main crewed platform, and employ layered escort jamming that degrades adversary fire control radars during transit and while on station. A network of unmanned aerial sensors can provide forward detection while keeping crewed platforms outside the most dangerous engagement zones. Similarly, dispersal and mobility of sensors and shooters complicate targeting by forcing the defense to spend time and munitions hunting moving contacts rather than concentrating interceptors on static emplacements. Electronic warfare retains a central role. Modern radars achieve exceptional sensitivity through large coherent apertures and digital processing, but they remain susceptible to degradation of their operational effectiveness when confronted with well-planned emit and deception campaigns. Adaptive jamming that alters spectral signatures, false target injection, and intelligent suppression of command and control data links add friction to the defender's kill chain and reduce the likelihood that every track will receive a timely interceptor. Pakistan's focus on improved electronic protection for its own data links and on offensive electronic attack to create windows of degraded sensing will blunt parts of the S-500 advantage by denying it optimal target quality during critical periods. Space domain resilience is another essential pillar of a comprehensive response. The S-500's claimed capacity to engage low Earth orbit objects elevates space hardening from theoretical to operational priority. Hardening means not only shielding and redundancy on satellites, but also architectural measures, such as proliferated constellations, cross-linking, so that the loss of one node does not blind the network, and rapid reconstitution options using hosted payloads or commercial satellite services. Distributed small satellite constellations that provide overlapping coverage reduce vulnerability to single engagement points, and rapid satellite launch capabilities shorten recovery timelines. Equally important is operational security for space command and control to hinder preemptive targeting through deception and denial. Missile defense is as much about command logic as it is about sensors and interceptors. embracing salving tactics that combine ballistic and cruise trajectories, employing multiple flight profiles, and integrating decoys and electronic countermeasures force missile defense systems into complex engagement dilemmas. Pakistan's development plans that stress multiple independently targetable re-entry vehicle deployment, penetration aids, and layered launch patterns increase the cost of successful interception and preserve credible second strike posture. That posture underwrites strategic stability by ensuring that any attempt to nullify deterrence would require prohibitive expense and risk. Operational survivability also depends on logistics and industrial resilience. Batteries and launchers for advanced air defense require complex sustainment, spare parts, and trained personnel. Targeting the logistics tail through legal, diplomatic, and economic levers rather than kinetic means reduces the risk of escalation while imposing real constraints on a deployed defense. Pakistan's own focus on deepening maintenance capacity, diversifying suppliers, and protecting critical industrial nodes enhances its ability to sustain operations under stress and to respond strategically rather than reactively. Diplomacy and arms control form the non-kinetic half of the answer set. Public technical transparency combined with active engagement in regional confidence-building measures helps shape political costs for ambitious procurements. Pakistan can press for verification measures, regional transparency, and reciprocal limitations that reduce incentives for qualitative leaps in capability. Working through international organizations and major power interlocutors creates pressure points that complement military measures and reduce the likelihood that a single technological acquisition will irreversibly alter strategic balance. Intelligence, attribution, and decision calculus must be sharpened accordingly. Detailed signatures of deployed radars, launch footprints, and engagement doctrine provide the basis for calibrated operational planning and for legal and diplomatic narrative control. Rapid, verifiable attribution reduces the fog of crisis and allows Pakistan to synchronize political, economic, and military measures that raise the threshold for any attempt to weaponize an advanced defense layer into strategic coercion. Investment priorities follow directly from this analysis. Pakistan should accelerate development and fielding of rapidly deployable small satellite constellations for redundancy, expand unmanned sensing and relay networks for forward detection, enhance electronic attack and protection suites for both sensors and shooters, and finalize doctrinal employment of multiple independently targetable re-entry vehicle-enabled warheads as a central deterrent element. At the same time, logistical depth, depot repair capacity, and legal diplomatic preparedness must be expanded to ensure endurance under protracted pressure. In summary, the S-500 Prometheus, if fielded as advertised, raises the technical bar for regional air and space operations, but it does not eliminate the strategic tools available to Pakistan. A combined approach that emphasizes asymmetric counters such as multiple independently targetable re-entry vehicle-equipped missiles, sensor distribution and redundancy, active electronic warfare, space resilience, industrial sustainment, and diplomatic engagement preserve credible deterrence while avoiding an unaffordable drive toward mirror image procurement. Pakistan's best response is not technical imitation, but coherent systems integration that converts technological limitations into operational options and sustains strategic stability across the theater. Thanks, and stay connected to the upcoming videos.